Hey everybody! Today I'm going to teach you about how to use the ROSOL command to create rotational solids, and how to use a set of points to create a Bezier curve. I'm going to start off by demonstrating how the ROSOL command works by explaining the current example that I've made here, and then going more in depth by showing you how changing the parameters affects the rotational solid in different ways. So first off, let's look at the example I've made, and then the code which made it. As you can see on the viewport, what we have here is a cylinder that we've made with its base on the XZ plane, which is reaching up the Y-axis. It has a base radius of 2 and a height on the Y-axis of 6. Now let's check out the code, and I can explain to you how we use the ROSOL command to make this. On the first line, we define a set of points with 2 points. I will explain exactly how these are used to make a rotational solid very soon. On the second line here, we create an object named myObject using the all caps ROSOL command. In the third line, we just display the object we made. The ROSOL command is used to create a rotational solid, and it does this through 2 steps. The first step is creating a 2-dimensional surface, and the second step is rotating that surface around an axis. The filled-in space from this rotation then becomes our rotational solid. The ROSOL command takes 3 parameters. The first is a list of points. This is used to create what is called a Bezier curve, which forms this outer edge of the surface. The Bezier curve is formed using some mathematics which you will not need to know because making them can be understood intuitively. I'll explain them soon. The second parameter is the number of degrees that you're rotating your surface around the axis to create the solid. The other 2 parameters control how the surface is made, but this one controls how it's rotated to make the solid. In this case, it is 360, to make the surface rotate 360 degrees completely around the y-axis. But if we change this to 90 and run our program, then the solid is made with a 90-degree counterclockwise rotation of the surface around the y-axis. And if we change it down to just a 1, and then we run our program, then we just have a thin sliver of our solid. This value must be greater than 0 for the program to run. I'm going to leave it as a sliver for a while so that you can better see how Bezier curves work on this outer edge. The third parameter is the minimum radius of our rotational solid. See, if we change the third parameter to a 1, and then we run our program, then the whole part of our surface within 1 unit from the y-axis is just empty space. The minimum distance of the object from the axis is 1. If this surface was rotated around the y-axis, then there would be a hole with a radius of 1 in the solid. So let's put it back to 0 and run the program. Our sliver is now back to normal, going from the y-axis to the edge. Now let's talk about these Bezier curves that I've been saying so much about. Bezier curves are formed from a set of points, like the one we have here named points. Right now, points just contains 2, one at 2, 0, and one at 2, 6. These are exactly at the corners here on our sliver, 2, 0 and 2, 6. This outer line of the surface is the Bezier curve. Because there are just 2 points, the Bezier curve is just a straight line. If we add in another point, however, a new curve will be made. I'll put in the point 0.5, 3 in between those 2 in the points list, and then I will run the program. Remember that order is important in the list of points. You want the endpoints at the beginning and the end of the list, and the other points in the order they appear between them. You can see now that it's no longer a straight line, but a curved line. Notice that the point, 0.53, is located about here, not on the curve. The Bezier curve isn't formed right through this point, but instead each point used to define it acts almost like a magnet, which attracts the curve to the point. More than 3 points can be used to define a Bezier curve, but for this example, I'm just going to leave it with these 3. Now let's make this surface rotate 360 degrees around the y-axis by putting a 360 as the second parameter, and then running our program. This is going to create a very cool shape. Look at this! It now looks almost more like an hourglass instead of the cylinder that we started with. Know that if we use more points to make the Bezier curve, then different, more complex shapes can be formed. To sum up this lesson on the ROSOL command to make rotational solids, remember that the ROSOL command takes 3 parameters. The first defines the set of points that will be used to make the Bezier curve, which will define its outer surface. Whose order is important? Remember that the Bezier curves do not pass directly through the points used to define them, but are more pulled to them, like a magnet. The second defines the number of degrees around the y-axis that you want to rotate your surface. The third defines the minimum radius of the solid, inside of which there will be only blank space. Experiment with different sets of points and different parameters for the ROSOL command and see what kinds of interesting rotational solids you can make.